Hello students, now let us see the problem number 5, that is in text question from the haloalkane and haloarenes. So what is the fifth question? They are saying, student, draw the structure of major mono halo product in each of the following reaction. So draw the structure of major mono halo product in each of the following reactions. So here is there, student, cyclohexanol is there and SOCl2 is reagent. So SOCl2, okay, what does it do, student? SOCl2 convert, what it can convert, student, that is OH group 2, OH group 2 convert or replace, that is OH group 2 Cl. Okay, so what would be the reaction? You can easily write down the reaction, student. This is the cyclohexanol, that is OH, and if you are treating with SOCl2, so what is there, student? This O oxygen and this SO will be releasing as a SO2 gas, okay, and another H, one H and one Cl minus HCl as a gas, and what is leaving out, student? Okay, if you see, so here not benzene ring, student, I am sorry, benzene ring will be not there here, don't get confused, student. Here is the cyclo is there, so here will be the, this compound is forming Cl. So if you want to write down the name of this compound, it will cyclo, no, this will, the first one is the chloro, we have to write prefix, then cyclo, okay, and then hexane, okay, and this is cyclohexanol, cyclohexanol, okay. Now next reaction, if you see, student, this reaction, so that is because of UV light, student, there will be substitution to the alkane. So what does it do, student? Okay, so Br2 in presence of UV light, in presence of UV light, in presence of UV light, Br2 in presence of UV light, Br2 in presence of UV light gives, what it will do, student? Br2 in presence of UV light gives substitution to alkane, substitution to alkanes, okay, substitution to alkanes, okay. So now let us see the reaction, student, how it will be proceeding. So this is the, benzene is there, so benzene ring is like that, and here is, that is CH2 and CH3, and here is NO2. Dear student, you have to keep in one thing in mind, that is what we are using, Br2 you are using, then you are using the heat, and secondly in presence of UV light. Suppose it is the dark reaction, so substitution of bromine will be in the benzene ring, but here is the light is taken, so the substitution will be here, student. So here is the product related with the benzene ring, and here is CH, and that is Br will be added here, and this will be the CH3, and this will be the NO2. So this is our required product. Next question, if you see, student, problem number 3rd. So what is there, student? HCl and heat. So what the HCl and heat, at high temperature, at high temperature, what it do, student? At high temperature, HCl, okay, replaces, replaces, what it will replace, student? Replace OH group by what, student? By Cl minus. So you can write down the reaction of this, student. How can you write the reaction? Directly I am writing the here reaction product, student. So what would be the product in this case? Like this. This is this OH will be, that is we are not going to replace the OH of the benzene ring, student. It will not replace the OH of the benzene ring. What is it will replace, student? It will be able to replace the allylic alcohol, student. So OH will be here as it is, and here it will be CH2 and Cl. This is the, always you keep in mind, this Cl can only replace the OH group of the alkane, okay. And now let us move another reaction, student. This reaction is there, okay. So this reaction with, you are treating with the Hi, and this is the unsymmetrical alkene. This is unsymmetrical alkene, okay, student, unsymmetrical alkene. So unsymmetrical alkene, if you are treating with HI and there is no other peroxide, that is will follow Markovnikov's rule. Okay, Markovnikov's rule. If it is following Markovnikov's rule, student, so where this where the hydrogen and where the I will be able to attach. Okay, so let us check it out, student, in this one. If you want to see, so Markovnikov rule said that is negative part of reagent will adds to that double bonded carbon atom. This is the carbon atom which have less number of hydrogen atom, so this is having 1 2 3 further. Here is no hydrogen atom and here is one hydrogen atom is there, student. So how the product will be there, student? Always you keep in mind that is less number of hydrogen atom is there with this carbon, no hydrogen. So here will be the I and here will be the H will attached. Okay, H will attach. So this product also can be written like that. This is the cyclohexane and here is the will be CH3 and here will be the I. This is our one iodo, one methyl cyclohexane. So it will be name, student, one iodo. Okay, on the same position there is methyl group, methyl. Okay, and that is what will be there, student, cyclohexane. Okay, next one, student, see, this is the halogen exchange reaction, student. This is the halogen exchange reaction and replacement, if you are using replacement by I. Okay, replacement by I, so that is known as what? This is the Finkelstein reaction, student. Finkelstein, Finkelstein reaction. So what is that? Is bromine is replaced by NaI, replace what it will do? Replace Br by which group, student? I. So let us write the reaction, student. What are there? CH3, CH2 and Br is there, and if you are treating with NaI, so what it will form, this, student? This is NaBr is getting out minus NaBr. Okay, and here it will give CH3, CH2 and I. Okay, this reaction is always takes place in the dry acetone. That also you keep in mind, student. Dry acetone. Now let us move another question, student. What is their 6 number? So see, student, Br2 is there and heat you are applying, student. Br2 is there and then you are applying the heat. Okay, so what kind of reaction it is? So UV light is there, again the UV light. So UV light, it will give the substitution reaction. Okay, not addition reaction. Not addition reaction means what, student? That is Br can't attach here and here. So what could be our product, student? Br only can attach this or this position. So both position are symmetrical, so it will go any of the position. So here we can write, student, this is the product, required product. Here you can put the Br and let it be the double bond as it is. So and along with that is HBr. Okay, so this is what, student, 3-bromo cyclo is there, 3-bromo cyclo. Okay, hexene. Okay, hexene, hexene. Okay, this reaction is quite easy, student. Sometimes student get confused, I don't know why. Firstly, you try to understand the reactant, student. This is there and each position there is hydrogen. Here hydrogen, number of hydrogen is 2 hydrogen are there, student. This is also 2 hydrogen, here 2 hydrogen, because single bonded compound means carbon valency 4. Now, student, what we are going, you are treating with Br2 but you are having the UV light, UV light. So UV light means it is good substitution. So one hydrogen, this hydrogen and one Br will be out. So minus HBr and remaining Br will attach here. So this compound will form, students. So easily you can understand. This is the Br and here is the double bond. So this is our required answer. Thank you so much for watching, friends.